Hello and welcome back to Chemistry with Kimberly. This is the Organic Chemistry series of videos, lecture video number 3. So as I mentioned in the previous video, if you master an understanding of how to create resonance structures and combine that with an understanding of acids and bases, you can master organic chemistry. So let's first talk about some rules for resonance. First, you should have a filled octet on the second row of elements. And by the second row of elements, I'm specifically referring to carbon, nitrogen, oxygen, and fluorine. You should have a minimal formal charge with a maximum number of bonds. And so what that means is that if you have an atom, if you're creating a resonance structure and you have a choice between an atom which has an unpaired set of electrons and a charge, or a double bond, you should use that unpaired set of electrons to create the double bond, which may either eliminate or change your formal charge. Third, you should have the negative charge on the most electronegative element. And let's spell charge correctly here. And so what I mean by that is that you should already know that carbon is less electronegative than nitrogen, which is less electronegative than oxygen, which is less electronegative than fluorine. And finally, you should have minimal charge separation, and you should keep your formal charges close together. So if you have a compound that consists of 4 carbons, and you can have a positive charge on one end of the carbon and a negative charge on the other, it is better to have those charges on either the first and second carbon or the fourth and fifth carbon. So let's look at some general examples of resonance structures. You have a compound with an unpaired set of electrons which is bonded to, you have an atom with an unpaired set of electrons which is bonded to another compound. We can create a resonance structure of that by moving those unpaired set of electrons into the same position as a single bond, creating an atom which now has a double bond. The reverse of that is to have a compound which already has a double bond, and we can create a resonance structure by moving one set of electrons to the atom, now leaving us with an atom with a single bond and a single set of unpaired electrons. So let's look at some real examples. This is a propene compound, which has you'll learn later, is a carbocation, or a positive charge on the carbon. It's a very prominent feature of SN1 reactions, and we'll learn about that later. I can create a resonance structure by moving a pair of electrons from the electron-rich double bond next to carbon, or onto the carbon, and I am now left with the compound which has shifted the positive charge from the fourth carbon to the second carbon. We can do resonance structures with oxygen compounds, or carbonyls, as we often come across them in organic chemistry. Here we have a negative charge and an unshared set of electrons on our carbon. To dissipate that negative charge, we shift this unshared pair of electrons here. And because we have to remember our octet rules, we end up with the charge now on the oxygen, which, if you remember our rules, is the more electronegative than carbon, and now we've created a double bond. Finally, we can also have resonance structures with benzene compounds. And you may remember that benzene is actually a hybrid of that compound and this one. So again, we're showing our electrons, but our double bonds, but they're positioned differently in a benzene compound. The circle represents the fact that it's a hybrid of those two compounds, this one and this one. So let's look at a benzene compound in terms of resonance. Here we have a benzene that's bonded to an oxygen, which now has a negative charge. Now normally we'd want the negative charge on the oxygen, so this will be the most stable compound. as you will see, because it ends up the most electronegative with the charge. But since we're doing resonance structures, we're not concerned right now with where our negative charge is, just in drawing the resonance structure itself. So we move a pair of unpaired electrons to create a double bonded oxygen compound, which now has 2 unpaired electrons, and we shift, when we move our bonds around, fulfilling the octet rule, we now end up with the negative charge here. When we draw an additional resonance structure, with that negative charge now moving there, we end up with this compound. And that bond will move there. We end up with this compound. Now our negative charge is here, and so we can draw a final resonance structure by shifting our bonds again. And we end up with this compound. So this concludes our video on resonance structures. Please feel free to leave me any comments or suggestions. Again, do as many practice problems as you can so that you can master resonance structures, which will ultimately help you master organic chemistry. See you in the next video.